I have here a Spring Reverb. I just bought this on Sunday from a car boot sale. There's no maker's name on it or anything. There's no idea of where it came from. So what I wanted to do is make a little Spring Reverb effect for the synthesizers. So what I am going to try and explain today, if you don't know, if you do, I apologise, is you can't just plug in a Spring Reverb and expect to use it, because you need some circuitry. This is the input, this is the output. Now, the problem with Spring Reverb is if you send a signal in here, you've got to power this electromagnetic coil here. And then the signal has got to be picked up at this end and turn back and come back to your amplifier. But it's very, very low. So you need an amplifier to put the signal in and an amplifier to receive it. That's called the recovery, that side is. And let me just explain something here. The thing with the Spring Reverb, yes, you can sort of tickle away with your finger and it makes lots of noise. But what actually happens in a Spring Reverb is this side actually twists the spring like that. It doesn't send a vibration in like this. It turns it. And then this side picks it up because it picks up this twist. And the way it does that is it has a magnet actually on the end of the spring, both sides. And that is generating an electromagnetism for the coil to pick up and send back. So it doesn't do that, it does that. Anyhow, cut a long story short, what I started to do is build the actual circuit up to make this. And what I decided to do was just use op amps. Op amps are very simple little devices. And let me just do a little basics of op amps. So you may see this symbol, and that is an op amp. So your signal comes in here and the amplified signal comes out of there. But that depends on several factors. Let's just, for instance, have that and the plus and the minus. That's not your plus and minus signal at all. That is just to invert the signal if you use the minus side, or have the signal the correct way around if you use the positive side, basically. So a simple circuit for an op amp. So let's say we're going to send our signal in here, and it's just a tiny signal. Okay, you would need a capacitor, of course, because you want to decouple the DC and just have the AC signal going in there, and you'll have the same sort of thing this side as well. Now, the way the op amp works is if we put a resistor here and put a resistor here to ground, and then you want your power pins as well. So let's say that's plus 12 and minus 12. You'd use plus 12 and minus 12 because you'd want the whole signal, the positive and the negative side of the signal coming out. And the op amp works better like that. You can do them with like 9 volts DC and things, but you have to kind of shift the signal up. But that's a whole other story. So what we got here, let me try and make this simple. So say we've got a 10k resistor here and a 2k resistor there. So what will happen is your signal going in, or your, let's say your gain equals 1 plus the 10k over the 2k. So 10 over 2 is 5, plus this 1 equals 6. So what we've got going here is basically if you send 1 volt in there, you're going to get 6 volts out of that side. And that's basically how the calculations work on a simple op amp amplifier. Now then, the problem is I need one of those for this side to amplify the signal going in so that it can energize the coil, and then on the other side I need another one of these circuits to amplify the signal so I can actually use the wet signal that's coming out of this side. Something like the TL074 will have 2 op amps in there anyway, but then 2's not enough for what I want to do, because I might want to mix a bit of the output to go back to the input, so I need another op amp. I want to maybe control it with a CV voltage control. That changes the story altogether. The easy thing to do there is use an LM 13600 or 13700, because you can control those with current, not voltage, current. So you would need another op amp to turn the voltage into current so that you can control this with a CV, and it starts to get really, really complicated, to the point where here's one I built earlier and it still isn't complete. So I've basically got the input coming out over here, the LM13600. I've got another circuit here that turns the CV voltage into current so I can control this, and then I've got another output here, and I haven't even put a mix circuit in there or anything. It just gets deeper and deeper and becomes a total rat's nest. So I was looking online and I found something that is cheap enough to just build, and it's going to do all the job for me. It even has Vactrol circuitry in there and things. So let me just show you that. So this is what I purchased, and it's for Eurorack. I want to get into Eurorack stuff. I know I've got the 5U gear, but I want to get into Eurorack as well. Now this comes from a company called Thonk, and I only just found out that they're actually within walking distance from where I live. But here is the circuit. This is everything I want, all in one little package. It's got all the components, all the hardware, the chips, the switches, the cables, the badges, the stickers. Yeah, all right. It's a nice touch. Stickers and things, I'll put those to one side. But anyway, this has got, it's got where you put the signal in. It's going to amplify it and send it to your Spring Reverb, and then it's got the recovery circuit, and that comes back on the out. It's got a crossfade type of mix, so you can, you know, I'm not actually sure what the crossfade does actually. I think the feedback is actually what feeds a bit of the output back into the input. I don't know until I've built it. It's got control voltage, tilt, yeah, anyway, basically it's all here. And I kind of worked out the price of this against building it yourself and having to source all the parts and everything is, well, it's actually cheaper. It's designed by Tom Whitwell in London. So yeah, I'm going to make this up. It's even got this Vactrol circuit, and I'm not sure what the Vactrol does on this until I've built it. So all I'm going to do in this video is build this up and test it out on this spring, and then test it out on this spring as well, see what the differences are. This has got 3 on it, this has got 2 on it. This came out of a Philips Philly recorder, an old 1960s/70s keyboard, and this came out of, I don't really know, haven't got a clue. It looks like an Accutronics, but Accutronics normally put their name on there, and this has got nothing on there apart from the date of manufacture, which is in 1977. So I must stress for this video, Thonk are not paying me to make this video, and I did purchase this. So, you know, there's if it's good, it's good. If it ain't, I will tell you. So let's go ahead and build this up and see my first Eurorack piece. So start off, lay out all your components, and everything's sort of written on each of the bags, which makes it nice and easy to find. What they've basically done here is this one contains 3 types of resistors. So to stop you getting sort of confused as to which resistor is which, because The colour codes are so tiny on these things, and they've got a brown stripe on one side of them, meaning they're 1% resistors, 1% tolerance, that is. That's a good thing. Now, as you see here, we've got 9 resistors there, 2 resistors there, 1 resistor there, and on the pack it clearly shows you the 9 is 100k, the 2 resistors are 6.8, and the 1 resistor is 15k. Brilliant. I like that. So don't take everything out of the bags and throw them all on your table, or else you're going to need a multimeter to check all the resistors, or really good eyesight. So you need a multimeter to check things as you go along, of course, and a soldering iron and a pair of side snips, and that is basically it at this point to construct the entire thing. Now, inside the box you do not get any instruction manual. There's no assembly or anything in the box, so you do have to go online onto the Thonk website, and everything is explained really easily, piece by piece, and what to start off with. So the first things to start off with are funnily enough, I picked up the correct bag first, the 9 100k resistors, as you see here. And these positions is the positions that's written on the board, if I've got the correct board, yeah. You can just see written along the top there. Sorry, don't know if this camera's going to see it, but that's that board, and it's got all the little arrows to tell you put all those 100k resistors there. You obviously solder the components onto the side that has the white writing and the legends and things on there. So if you've got one of these little handy tools here, you can hold the circuit board, and as you put the components in, the legs can stick out of the bottom, and it just makes things easier. But if you haven't, you can equally just get 2 bits of wood or 2 bits of anything and just place it on like so. And it'll do the same job, because putting all the resistors and the bits and pieces in with the legs actually sticking through can be a little bit awkward, and this tends to make it easier. Another thing is, when you bend the resistors, let me just check I'm going to put this in the right one, 2.2 goes in there, push it through, and then just ever so slightly bend the legs out a little, and that holds everything in place for you to solder them. They won't fall out then. Now when you come to the diodes, these are pretty simple. You'll see there's a silver line at one side, and on the board you'll see the symbol of the diode, and there'll be a line. So this one has to go that direction, and this one has to go in the opposite direction. This, judging by where it is part of the power safety, so you can't put in the wrong power. Now if you put either of these in the wrong way round, the whole thing just will not work. Now when you come to the IC sockets, unfortunately, when you put them in like that, you can't really bend the pins over on the back to hold it into place, so that when you turn it over, the thing falls out. So what I tend to do is put a little bit of solder just on one of these pads, like so, just in the corner. There you go, like that. Okay, and then get the IC socket. Remember, there's a little notch in it, and that notch has to line up. So the socket won't push through because the solder's in the way now. But if you flip it over, as long as you don't burn your fingers, and just heat that up, there you go. Now that has held it in place so that you can solder all the rest of the pins. When you come to solder the pin headers, the best thing to do is just solder one of the pins, one in the middle somewhere, and then you can reheat that up and rock this side to side until it's dead level. Or if you solder all of the pins and then turn it over and find they're all facing that way or that way, it's a bit awkward to try and correct that afterwards. So it's better to just do one pin first, get it absolutely level, and then solder the rest. So there you go, it's all complete, all together and all lit up. And yes, I have had a little play. Works very nicely. This is the unknown brand Spring. So I can't tell you what that is, haven't got a clue. But it sounds rather nice. What I've also done, I'll test it in a moment, is I've put some phono sockets on the Philips filicorder spring as well. This has got 3 springs in it, and it's about the same sort of length, but obviously there might be a little bit of a difference. So I'll just run a sequence into this. I've done a little sequence with some high and low notes in there, nothing great. Please don't judge me on the music. And I'll have a play with this and see what happens. So this is completely dry, no spring. So if I start to bring it in, there we go. Very nice. Bit of feedback. The tilt control. Now, that was actually a reasonably easy build. I mean, all the instructions and everything was very simple. I like the way everything was bagged up into numbers of resistors and things, so you didn't really need a multimeter to go through them or eyesight to read all the colour codes on them. So you don't really need a multimeter. You do need a soldering iron, of course, and some side snips, but that's basically it. That's all you really need for this kit. And I'm happy to say this is actually my first Eurorack piece. I'm hoping to put a bit of a Eurorack gear together. So looking at that against the one I built earlier, which doesn't do half of what this does, I guess Tom Whitwell, who's designed this, has done a much better job than me. So thanks, Tom, you've saved me lots of time. The amount of time and effort that goes into trying to design and put something like this together, you know, if there's something out there that you can put together and build yourself, okay, from somebody else's design, then, you know, it actually works out a lot cheaper in time and expense. So yeah, I'm quite happy with that. Very nice. Now, I'm going to change this tank for the Philips filicorder tank and see what it sounds like through that. So this is out of an old 1960s Philips filicorder. Very nice. Works all right. All I've done is just put some phono sockets on there. And they have different impedances and things, but this is handling it no problem at all. So let's hear what this one sounds like. Brilliant. Yes. Let's play the music a second. Bit of tilt. Bit of feedback. Okay, very nice. Yeah, brilliant. What can I say? Nice, easy project to put together. It looks a little bit dense, I know, with components, but like I say, everything is really easily set out, and everything's on the Thonk website. And as I said previously, I actually purchased this. This has not been sent to me to sort of demonstrate or anything. this is my first bought piece of Eurorack gear. So there we go, part 1. So if you found that video interesting, please give us a thumbs up, and well, I don't know what my second piece is going to be. Any suggestions what I should have next to this, apart from a box, of course? I have to either make a box or buy a box. I've got the power supply. It's not a very brilliant power supply, but it does the job. So yeah, any suggestions what my next piece should be? Because I'd like to build up a nice little Eurorack to put in my workroom, because the big synth gear is all in another room and I have to keep on going in there to play it. So thank you very much. Give us a thumbs up if you like that, and all the best. Thanks for watching. Bye bye. This isn't going to fit.